Okay, vectors in Zig. Okay, we're gonna do vectors in ArrayList because this is something that might confuse people. All right. In Zig, let's just look at the documentation. It says Zig provides vector types for SIMD, right? Multi-threading or whatever, right? There are not to be conflated with vectors in mathematical sense, or vectors like C++. Okay, in C++, a vector is basically an array that can shrink and grow. Okay, with vectors in Zig, there can only be three types. It says vectors can only have three child types: booleans, integers, floats, and components. And pointers. Okay, and the thing about that is a vector cannot grow. So they're false types. This is not like vectors in C++. Okay, we're gonna go over ArrayList too in this video. So let's get into it, right? All right. So so we'll do it like we used to it. So we'll const std, we'll add import std. Okay, public function main. We put that void there because it's not going to return anything. Okay, and we have to import a package for vectors, or a standard package. So we'll put constant vector, and it's at import std.meta vector. Okay, terminate that. All right, so when we declare a vector, right, we're gonna go constant, let's say v, and we'll say vector. We have to declare how many we have, and then the type. So it's gonna be I32. Okay, and we're gonna have 4 of them, right? Then we'll just make this easy, and we'll put 1, 2, 3, 4. Okay, perfect. Let's just make sure that compiles. Expected. Okay, let's just make sure that compiles. Zig run. What is this? Arraylist. Oh, I didn't put the equal sign there. Reference. Okay, I made a mistake. You don't import it like this, right? Okay. Just make sure that compiles. Okay, that compiles. Okay, so we can just print this out regularly. Debug. Just not print line. Okay, put that dot there, and we'll put V. Voila, we just printed out everything, right? Now, you cannot use like the for statement, right? Basically, I think I covered this in a video, right? I did. Maybe I did, maybe I did. Okay. All right, but for, this is like a for each loop if you look in other languages, right? So we're taking this. This is from a song. Hey, daddy, baby, I got your money. It's an old dirty bastard song, whatever, right? I don't know why I put that, but I did, right? All right, so it's just going to take L right here, and then it's going to take for each element in L. It's just going to loop through and print out, you know, because I put it says print here because I put the whole thing up here, but it'll just print out each one, right? With an array list, you cannot. I mean, with a vector, you cannot do that. You have to use the while statement. Okay, so while. First, we got to declare a variable, right? We'll say, no, this has to be a var because it will change. and then we'll make this a U32. It has to be unsigned integer, right? Okay, and then we'll put I less than std mem length of v. Okay. All right, now what we're gonna do is okay, so we'll print this out now. Dot debug dot print line, but not print line, print. Okay, I don't know why it does that. Okay, so we'll put v and then I in here, right? Would be nice if we could just put I plus plus, but we can't. I plus equals 1. Okay, now this will loop through. Let's see, it looks like I have an error somewhere. Oh, right here. Okay, there we go. Okay, so let's see what we got here. Now you see it'll print out 1, 2, 3, 4, and it'll put a line in there. So this is how you loop through those variables, right? Now we can do something functional, like let's say we'll say var sum is equal to I'm killing that, just did too much go. All right, var sum, and we'll make this I32 equal to 0, right? And this is in here too. This is in the documentation, right? You can see, we can see at splat here, right? I'm gonna find out if they have some documentation for this built-in function or whatever, right? But you have the splat, and this basically is gonna go through each element and do whatever operation on each element, right? So we'll just do this in our thing. You know what? We'll just cut and paste this, right? To make this simple. Okay. So we'll put total. Or no, this is going to take everything in. Okay, so we'll make this times 2. Okay. Okay, so let's put result. Okay, so we'll put time. Just had a brain fart for a second. Let me take a look at that again. Not vector, blah blah. Okay, for each. All right. All right, we'll make this. We don't really need this variable. All right, sorry, I confused myself during this video, right? So we're gonna take v, right? We're gonna take v, this vector, and it's gonna go through all of them. And since we have four values inside of here, right? It's gonna take all of them and times them or multiply them by 2. We'll make it 4, multiply them by 4, right? And this will give us a result, right? So we'll just take this, make this easy on ourselves. And we'll put result in here. Okay, so zig run. Okay, put the wrong value in here. You got to put this as a. You got to put this as I32. There we go. And it times everything, it multiplied everything by 4. So 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16. Okay? So this is going to be vectors right here. Right now we'll move on to array lists, because they operate kind of weird too. So, or differently, not weird. Let's say differently. Okay, let's go up here to array list. Okay, basically the pattern for creating an array list. Okay, now these array lists can shrink and grow, right? It says the std array list is commonly used throughout Zig and serves as a buffer which can change in size. See, the array list is similar to C++ vector or Russ's vect, okay? And the dnet method frees all array lists from memory, okay? All right, so these can shrink and grow. So here's going to be the pattern basically right here, right? You're going to declare it, and you're going to use an allocator, right? Go check back on my video on allocators so you can know what they are, right? And then we're going to defer this dnet. So this is going to free up the memory at the end of the program. This is going to defer this to the end of the program. And then you keep just depending, right? Okay, so let's go into one of my examples. I'm not going to write all this code, right? All right, so doing the same thing here, right? I have a fixed buffer allocator, right? Let me go over to fixed buffer allocator. All right, the std heap fixed buffer allocator is the allocator that allocates memory into a fixed buffer and does not make any heap allocations, right? So this is gonna allocate memory on the stack or whatever, right? Okay, so we got a fixed buffer allocator, and this is going to be of 1,000 U8s, right? It's way too big, but I'm doing this just for an example, right? Make the allocator, make a reference to the allocator, and then we initialize the allocator inside of the list. And this is going to be, list is just array list. I just called it array. I just called it list for short, right? And it's going to be of U8, so it's going to just be characters or whatever, right? And var L, and the variable is going to be L. So now we're going to append a slice to it, right? And so we're going to put hello U, right? Okay, but here's the issue, right? Here's the thing that's funny about this, right? Let me comment this out so I can show you what I'm talking about. All right, let me see if this works. Okay, std debug dot print. Okay, and we'll put in here. I think I got to put an S in there. Then we'll put L over here. Memory allocator. I kind of figured that was going to happen like that, right? Let me see if it does it like this, right? Okay, well, what we have to do here is we access it by the items, right? But the funny thing about this is, right, so it's L.items. I thought it was just L, but it's L.items. Items. Okay. But you see, it doesn't print out separate, it just prints out the whole thing, right? So it just basically is a big pool of memory that you just drop stuff into, right? So if I was to take out this, right, it would take the variable, right? So I'll put this in here, right? It'll just combine those two variables together, right? Okay, so you always, it's just a big pool of memory, right? So what you have to do is you end up splitting it, right? Okay, so you split it, do a mem split or whatever, and in this case, we're going to split it by a comma, because I put a comma up there, right? and then you can see that it split 1 and then 2. You know what? We'll just take out one of these right here, just so we can show this. Okay, and it prints out hello, prints out the first one because it's split. And it's split, when you split something, it returns what you call an iterator, right? If you go down here, right? Okay, and you can see this just basically the same idea right here, right? And you can go through it, but you got to use the next, and this is actually optional because the next thing could actually be nothing. So another thing you have to end up doing is you have to catch any error up here in the main function, right? All right, and we can loop through this like this right here, right? While the iterator, for the next iterator, and it'll keep going till it stops, right? But that I thought that was different. That's different from any other language I've ever seen, where it just makes a big pool of memory, and then you split it yourself, right? So, I hope this gives you a little bit of clarity on it, because these work a little bit differently, right, than anything else I've seen. All right, so thank you for your time and attention. So, you know what? Let me run this so you guys can see what I'm talking about. There's one other thing I wanted to show, right? And hold on, let me save this, right? Okay, you see how this does hello, and this only prints out you because we've already used one iterator. Once you do this one time, every time you do this, it just keeps going through. So it's going to show, this hello is coming from here, and the you is coming from here, right? So it starts where you left off when you do the iterator, right? So let me just take this out, and then and I'll put a arrow in here just so we can see what we're talking about, right? And then you can see that it'll do both of them, right? But let me put that back up there. All right, and then you can see that this U is coming from down here. Now, what if we do this again? What if we do another iterator, right? Because I got to put another S in here. You see hello U comes from here, but it doesn't even run this because all of the iterators have dried up or have been used up. All right, that was the last thing I wanted to show about that. But thank you for your time and attention.